Welcome back. These are the notes for 7, second half. My video stopped recording yesterday and I don't know why. So I'll just record these last few examples. Example 4, use an inverse trigonometric function to write theta as a function of x. So when we write something as a function of x, that means that it's going to say theta equals, and the variable on this side is going to be x. So I'm going to look at this triangle, and according to theta, we know the opposite side and we know the hypotenuse, which tells us that we can find the sine of theta by putting the opposite side over the hypotenuse. Now to get theta by itself, we have to undo sine, and to undo sine, we're going to use arcsine. We need to do that to both sides of the equation. And that will cancel out the sine, that will undo sine, we'll get theta. And on this side, we will have arcsine of x plus 2 over 5. And that's all we have to do for that one. Example 5, now we've got composition function, and these are all without a calculator. So it says sine inverse 3/5 on the inside, so that's the first thing that I'm going to do. But because it's without a calculator, these are not special, like these aren't the ones that I memorized. I'm going to have to graph them and figure it out. So if I go and I look at 3 over 5 being y over r, then my y value would be 3, and my radius would be 5. And because we have sine inverse, we're going to be using those domain restrictions that say go from negative pi over 2 to positive pi over 2. Let me go that direction. So this is a positive, so we will be in the first quadrant, and y will be 3, and my radius will be 5. So my theta is located here. So this is just basically saying where is sine 3/5? Well, it's right here. I don't know the number, I don't know the degrees or the radians, and I can't find out without a calculator, so I'm just going to call it theta. So now we're going to take cosine at that exact same location, theta, and take cosine of theta, and cosine is x over r. So I just need to find x, which this is a 3, 4, 5 triangle. So 4/5 will be the answer. Example B, inverse cosine negative 5/7. So if it's negative, cosine goes from 0 to pi. If it's negative, it's going to be in the second quadrant. And r can never be negative, so that means that the x has to be negative. And we have to find the theta. Well, here it is. So now we're just doing tangent at that same theta. And tangent is y over x, so I have to find the y value. This is not a triple and it is not a special right triangle, so I'll just use Pythagorean theorem. Do 5 squared plus y squared equals 7 squared. So we get y is 2 radical 6. 2 square root 6. So I'm going to put y, 2 square root 6, over x, which is negative 5. So I'll put that negative in front, and we are done. And then cotangent inverse 4. So I'm going to start with my cotangent values that go from 0 to pi. And this is a positive 4, so we'll talk about it being in the first quadrant. And there's my theta. Cotangent is x over y. So this will be 4 over 1. My x value is going to be 4. My y value is going to be 1. We have to find cosecant. Cosecant theta is y, sine is y over r, so it's going to be r over y. So I need to find my radius. Do 1 squared plus 4 squared is my r squared. So 17 is r squared, so r is square root 17. So my cosecant theta is the square root of 17 over 1, which is square root 17. All right, we've got arc sine x minus 1, and sine's going to be from negative pi over 2 to positive pi over 2. And I'm not quite sure if it's going to be negative or positive because it's x minus 1. But it's not going to really matter so much because x in this, we're finding secant, which is r over x. And x, if it's here, or x, if it's here, it's going to be positive still. So it doesn't really matter which one I use for this one. So the sine value is x minus 1 over my radius, which is 1. And we need to find the x value. I'm going to call that b, since we already have some x's in this triangle. In order to find a missing value when you know two sides of a right triangle, is we're going to do the Pythagorean theorem. So we'll do x minus 1 squared plus b squared equals 1 squared. So we'll have b squared equals 1 minus, and I'm going to go ahead and square this, x squared minus 2x plus 1. So b squared equals 1 minus x squared plus 2x minus 1. The ones will cancel out. The order that these are written in, negative x squared plus 2x, is totally fine to bring down. Or if you don't like the negative in front, you can write 2x minus x squared. Either would be fine. Now we have to find secant, which is radius over x. So we'll do our radius, which is 1 over our b value. And we have our secant. Now, normally we would go ahead and rationalize that, and you're more than welcome to rationalize it, but since we're just writing an equation of the secant, we don't really need to do that. If the directions were to write it in simplest form, then we definitely would do that. Okay, and then finally we're going to sketch a graph of the function, and this is arcsine. Arcsine is the inverse of sine, and when we were graphing inverses before, we would take the points for the original function, and we would just switch the x and the y. And that's how we would graph our inverse functions before. So I'm going to do the same thing. But I am going to start with, for the x values, I am going to start with the x values that go from negative pi over 2 to pi over 2. Just because that's what we use when we do arcsine. So I'm going to go ahead and start with those function values instead of the ones that I would normally use for sine. At 0, sine is 0. At pi over 2, it's 1. At negative pi over 2, it's negative 1. And then in between, these are radical 2 over 2's, which I just stuck in my calculator. So it's negative 0.7. Oops, this would be positive 0.7. Okay, so now I'm going to go ahead and switch x and y. So now our x column is going to be the old y column. And our arc sine will be the old x column. And so this would be the arc sine function values. But here we have a transformation that says translate one unit to the right. So on my x side, I will add 1. And then I'm just going to take those new values and graph them. I need to zoom out a little bit. In class, I said I wasn't going to give you guys graph paper with the graph paper that looks like this, and you guys can just sketch a graph and just make your own. Make your own graph. It doesn't have to be that accurate. We only have like 4 of these. But I just did it for notes just to really see what it looks like. So at 0, I've got negative pi over 2. At 0.3, I've got negative pi over 4. So 0.3 maybe approximately here, negative pi over 4. At 1, it's 0. At 1.7, pi over 4. And at 2, it's pi over 2. So there's a little bit of concavity that you can see with this graph. Make sure that I emphasize that concavity. Okay, and then this graph ends with points because the arc sine has to only be between pi over 2 to negative pi over 2 so that it does not fail the vertical line test. So this one is going to end. If we did have an arc tangent, the arc tangent would have like some asymptotes, and it would go on forever. But that's the only one that would go on forever, would be like arc tangent or arc cotangent. Okay, you have an assignment that's partially on a worksheet and partially in the book, and an upload will be coming soon. Have a great day.